Hey guys, welcome. We're going to continue on with 6.2. This next example is asking us to find whether these three matrices are orthogonal sets. So all we have to do here is just verify that the dot product of each individual matrix is equal to 0. And that's it. So to keep this simple for us, what we're going to do is we're going to make this matrix U, this matrix V, and this matrix W. So guys, all we have to do is just check the dot product of all three sets. So is the dot product of UV equal to 0? Well, 1 times 1 plus -1 times 1 plus 0 times 0. And that is going to give us positive 1 minus 1 plus 0 equals 0. So that's our first check. Then we're going to do we're going to do VW, which is going to be 1 times 0. And you guys can see it, here. I know you guys could you don't really need me to write all this stuff out, but it's just nice. If I did ask you guys to tell me if it's an orthogonal set, I would like to see the work for this. I'd like to see the actual values themselves. So this is what I'd be looking for an assessment. But again, 0, 0, 0, right? Pretty easy. 0, 0, 0. So that's clearly 0. And the last one is UV, or sorry, UW, a dot product of 0. And so 1 times 0, -1 times 0, plus 0 times 1, and we get 0, 0, 0 again, so we get the answer of 0. So we can say with certainty that yes, these are an orthogonal set. Okay, so you guys can probably try example number 6 without the help, but yeah, we just have to do it again, so let's do it. So are these orthogonal set? So we'll do this again, where we're going to test the three sets. So U times V, well, dot product of V. So we're going to have, just so to save a little bit of time here, guys. So 5 times -4 is -20. And then we're going to add -4 times 1 is -4. 0 times -3 is 0. And then 3 times 8 is 24, positive 24. And we get that this ends up being 0, right? -24 plus 24 is actually 0. So we're good to go with that problem. All right, then we're going to try VW. All right, so VW, again, -12. We're going to add 1 times 3 is 3. Add -3 times 5 is -15. And then we're going to add 8 times -1, which is -8. And then when you add all of these up, you actually get -32. So since this does not equal 0, we can stop right there. We do not have to keep going with our problem set, and we're going to say that this is not an orthogonal set. Okay, so it's that simple, guys. So the question number 7 is telling you that it will be an orthogonal basis. So show that U1, U2, U3 is an orthogonal basis because of the word orthogonal, right? So we've already talked about what bases are already, but what orthogonal means is that the fact that it's going to have a dot product of 0 for both U1, U2, 0 for U2, U3, and then U1, U3. So it's asking us to show it's orthogonal. So it's just another way of saying, is this an orthogonal set? And this is telling you that it is. So in this particular case, orthogonal, again, sets means that, again, all the dot products are end up being 0. So we're going to do this one more time. A little tediousness, but again, we'll do some time here. So we're just going to verify, and this is where you would show the work, right, for this to verify that this is an orthogonal set. So 3 times 2 plus -3 times 2, and then plus 0 times -1. And if it tells you to show that it is, then it's going to work out nicely for you. So you guys can see this is +6 plus -6 plus 0, which is going to give you 0. So that checks out pretty nicely. So again, it gives us the idea that we already know what our answer is going to end up being here. And then we dot product U2 with U3. So we're going to go ahead and do 2 times 1. And then we're going to do 2 times 1. And then we're going to multiply -4 or negative 1 times 4, and we get that this is 2 plus 2 minus 4, which is going to give you, again, 0. So again, we already know what these answers are going to be. And so just do another quick verification for this. We're going to do U1 with U3. And so we get 3 times 1. We're going to add to that negative 3 times positive 1. And then we're going to add to that 0 times 4. And we get positive 3 plus negative 3 plus 0 is equal to 0. Therefore, we can now say that U1, U2, U3 actually spans. It spans, therefore, an orthogonal basis. And my handwriting is getting really bad there, so I apologize for that right now. Okay, so that's it. That's all you got to do for this particular common thing. So, all right, hope that was helpful. Not too bad, and I will see you guys in the next video.